So thanks for having us, by the way. Really, SANS is such an amazing organization. It's such a pleasure to be here. My name is Etan Basseri. I'm joined by my colleague.
Bailey Bursick, nice to see y'all.
So yeah, we want to talk to you about some of the emerging threats that we're seeing against cloud app identities. And of course, most importantly, what are the things that you can do about it today? Now, as we go through this presentation, we want to just keep an eye on the North Star here. The North Star is eventually, and when we think about identity in general, it's about preventing unauthorized access, in this case, to a resource by an app or a service. And we'll talk through all of those details, but that's really our North Star, is preventing unauthorized access, right? Here's a quick look at our agenda. We'll walk through what we mean when we say risk in this particular context. How can you go about detecting those things on your own? How, once you find something bad, can you contain, mitigate, and remediate that? And then how to be proactive, how to protect against these sorts of threats in the first place. And the good news is, I'm going to give you a little spoiler here. The good news is a lot of the things that you might be doing already in your environment around identity for users are things that are going to be transferable to this category of threats as well. So I want to introduce you to this concept of workload identity if you're not familiar with it. A workload identity is a non-human identity. There are several kinds, right? With human identities, you're probably familiar with having employees and maybe business guests and things like that. With machine identities, this could be devices that are used by employees. It could be Internet of Things type devices, devices connected to an intelligent edge, or a workload identity. And so the workload identity includes things like all of your application identities, all of your daemons that are running, all of your managed identities that you might be running in Azure, for example. All those things are the focus of today's chat, right? What's important about these things is that these identities do not need a human present to authenticate to an identity provider. So with regard to app security, this is the identity that the application must have to acquire a token to get access to something. So if you're using a centralized identity provider to manage access in your environment, these are the things, these are the identities that you need to be aware of. Permissions, there's all sorts of ways that permissions get managed, but the thing to remember is that JIT and privilege escalation and all these sorts of things, they don't really exist for non-human accounts. What typically happens is you set and forget the permissions and access for these things because they're not humans, they don't know how to JIT up, right? A few examples for you. Service to service is another term that's often thrown around for these. So you can imagine a data backup service, right? It's running on its own in the middle of the night. CRM system that needs to sync. Even security software that's supposed to protect your environment itself needs to run in an automated way without a human being present, right? There's this joke. So I love cognitive biases. I think they are such an interesting window into how our brains are wired. One of the cognitive biases that I think, when we think about how we got here, has to do with the streetlight effect. So there's this joke, there's a man searching on all fours underneath a street lamp, and a police officer in the middle of the night, police officer comes by and asks him what he's doing. He says, "Oh, I'm looking for my keys." So he joins him. And after a few minutes, the police officer says, "Are you sure you dropped your keys here?" And he said, "No, I dropped my keys back in the park." And he said, "Well, why are you searching here?" And the man says, "Well, because this is where the light is." So in my view, the aspect of user identity security has been the thing that we've shown a spotlight on in the security community for many years. We've been aware of the phishing attacks and the password spray attacks and other brute force attacks and all these kinds of attacks against users. They've been visible and well documented. And there's been a lot of progress made to start to secure users against those types of threats. But right outside the edge of the light has been this category of workload identity security, this soft underbelly, if you will, of a customer's environment, where we know that there are attacks that are starting to emerge, but we haven't shown a light enough on the actual threats that are coming about and why those threats are there, why those weaknesses are there. And so hopefully this is going to shine a light on some of that for you. Just a few numbers for you, and sorry, this isn't exactly rendering perfectly on the screen, but we'll share the deck with you afterwards. So 34% of organizations suffering from security incident from a malicious application. 74% of organizations unaware of the number of digital keys and certificates, right? These identities are using all sorts of credentials different than that of users. And it's very, very hard for organizations to get their arms around the actual estate of all the different types of credentials and many of the applications that might not even belong in the organization anymore. And of course, aside from the numbers, just the headlines, right? I mean, this is an example, the SolarWinds, SolarGate, as we call it, event that happened about a year and a half ago, or was discovered, I should say, a year and a half ago. It actually happened about two years ago. Was the really historic level of sophistication and brazenness that we saw by Nobelium, which, although it had many aspects to it. It had aspects of hybrid compromise. It had aspects of application compromise as well. It really highlighted how applications can be used as an attack vector, and just how urgent it is that as a community, as an industry, we take a very, very serious look at the investments we're making, and we execute to start providing stronger defenses in short order. Now, one thing that we've known about for years is the aspect of consent phishing attacks, the threat of consent phishing attacks. I'll walk you through the example, but it's not news to anybody here. And another thing that's been even known for probably even longer is the aspect of credentials in code, knowing that many application developers, unfortunately, have a practice of putting their credentials in plain text in code repositories, often public code repositories. This even came up during the SolarGate example, where there was an update server that had a very simple password in plain text. So this has all been known for a long time. The issue is that the prevalence and the frequency of attacks against these identities now is becoming such that we can't ignore it anymore. It's becoming as important as the things we care about with users. And so to help you get your head around this, I have three basic categories for you to think about. You have your compromised apps. Those are legitimate apps. They belong in your environment. If they get compromised, they need to be remediated and brought back online. You have malicious apps. These are applications that are not legitimate. They don't belong in your environment. The only correct remediation path is for them to be removed. And finally, you have these misconfigured applications. These are ones where you might not have evidence of compromise, but you have a configuration in your environment that is so extreme that you treat it as breached, right? You have a zero trust concept of assumed breach. So we assume that it's been breached because, let's say, for example, you have a credential in code sitting out there on the internet. So let me take you through a few examples with the attack graph. So in the first case of a compromised application, the admin, basically what will happen is you'll have a compromised cloud admin either through password spray or through phishing or some other mechanism. And that admin is actually going to, the adversary is going to impersonate the admin to add credentials to that existing application. This happened during the SolarGate event. And then that application is impersonated to get access to whatever resources it's after. In the aspect of a malicious app, you have a phishing email. The initial user will consent to that application, and then the adversary will either impersonate that user to do one of two things: either directly access the resources it's after, or try to phish other users in the organization using the trust of that initial user because they're an employee, coworker, right? And then finally, with the misconfigured app, we talked about the idea of this leaked credential. And so you have a leaked credential that's somewhere on the internet, oftentimes in a code repository. And then those credentials will be used to impersonate the application from elsewhere on the internet. It's used often to enumerate the directory to find out what this particular application or who has access to what, and then go ahead and call those APIs. So those are some of the patterns. And obviously, I've simplified these examples for brevity and clarity. But this gives you a sense of some of the main vectors that we're seeing lately with application compromise. Now let's talk a little bit about how to detect these. The first source you're going to have is your sign-in logs. Every identity provider provides sign-in logs. And when you look at the sign-in logs, you'll want to look at a few key things. You'll want to look for a location. So you should know, in general, you'll want to know, like, what's the normal baseline for what location is. In fact, baseline is going to be important for all of these things. What's the normal frequency for my application to be signing in? What sort of user agent does it use? Is there a credential type that I expect? And conversely, is there a credential type that I should never be seeing? For example, some organizations, rightly so, have a rule that says you cannot use secrets for applications running in a production environment, right? Because a secret is just a password. It's just a simple string, right? And we want something stronger. We want an X509 certificate, something like that. Finally, with the resource, you might have an application that typically accesses mail, and now all of a sudden it's accessing SharePoint or some financial application that it's never accessed before. Looking for those types of anomalies is important, but you need to have the baseline. Audit logs, similarly, establishing the baseline to understand what's normal and what's not normal. Permissions is one of the most important ones, so take a close look at that one. Also, with time and process, we've seen, as everybody knows, adversaries will oftentimes make changes to a directory outside of normal business hours to try and obfuscate their activity or have it not pop up. With applications, you need to be particularly aware of changes to like the URI or to the logout URL. So these are things that will redirect the end users to different places, and you need to be aware of those types of changes that are happening. So it does require taking a close look at these log sources. The other thing I think is really important is the aspect of secret scanning. So if you're using whatever GitHub or GitLab or Azure DevOps, whatever repository you're using, you can use your own tool. There are open source tools out there. There are also a lot of tools built by vendors. Amazon has, a way of sending you an automatic email if they think you've checked in a secret. GitHub certainly does this with secret scanning. GitLab, I think I was just looking last week, has some tools as well. So, you're going to get more recall. You're going to have more scalability if you use some of those vendor tools. But you can certainly also use your own tools, especially if you have certain parameters that you want to be searching for and all of that. But basically having the secret scanning being part of your security program is super, super important. Now, for the containment, mitigation, remediation, I want to turn it over to Bailey here and have her walk you through some of the steps that you can do.
All right, thank you. And so to kick this off, I think it's important to review some incident response basics. And sometimes these things feel very basic, but in the moment when things are stressful, when something is happening, these are the things that often get neglected. So first of all, remember to stay calm and do no harm. You could potentially avoid, or you want to avoid data loss or loss of evidence and just prevent covering up the bad actors' tracks for them in those moments. Also, be sure to involve your legal team, especially if this is something that could have the potential to be much greater. You never know the full scope of something when you're first investigating. So involve your legal team, and as you do investigate, be very careful with what you share online publicly. Wait until the legal team gives you the go-ahead before doing so, just to not complicate matters even more. And also get help when needed. So I feel like these things are very elementary, but again, they're just very good reminders in the heat of the moment when things do get very complicated. Now, building off of those basics, what's more relevant to the topic today is containment. And when we say disable the compromised application, that's a little more complicated. It's easier said than done. And the reason for that is you have to weigh the security and the business impact of that app. So for example, let's say that your organization is in healthcare and that application may potentially be allowing doctors or surgeons to log in to then get the information to perform a patient's procedure. When it's a matter of life and death like that, you really just can't disable the application to begin your investigation. So every business is different. And if it is helpful for your organization, perhaps make a list of those very high business impacting apps, medium and low business impacting apps, so you can act accordingly in the moment when that time comes, or if that time comes rather. Also, if that happens, you would need to weigh the impact of that deletion and also keep rolling when that step is there. Now with recovery, after you go through and decide, hey, we're going to disable this application, or maybe you've waited a little bit and then now you've decided to disable it, go ahead and disable or delete those malicious apps based off of whatever guidance you have pre-decided on, remediate service principals, and remediate those affected service principal resources. Something else, if you do use Azure AD, you can implement identity protection for workload identities, but if you use any other IDP, feel free to use an analogous product that does the same job. Now, something that I really want to share with y'all is our incident response playbooks. And this is something that our team has been working on for quite some time to put together. So this is kind of an eye chart, and I don't intend you to actually be able to read this picture on the right-hand side, but I just want to show you the level of detail on this flow chart to kind of make some of those decision processes easier. So the IR playbooks are, they have multiple different sections that cover everything from the investigation process to what to do when an app was compromised, assessing that business impact, and the recovery process. So I know we only have 35 minutes today. Ideally, I would go deeper on each of these areas with you, but this is a great resource that you can leverage. And again, whether or not you use Azure AD, these same principles still very much apply to these types of situations. Now, okay, if you've already gone through this process, you've detected, you've then contained, mitigated, remediate, you're probably now thinking, oh gosh, what do I do to protect my organization from this, to prevent something like this from happening, or to prevent something like this from happening again if this has happened to your organization? And I think that we tend to complicate workload identities or anything that kind of comes out that's new, but really this is something that all the folks here I'm sure are familiar with, which is just securing your user accounts. And it all goes back to those same good security principles that I'm sure that you've learned through other SANS training or other your experiences as a professional. So those four security principles I'm going to dive into, and I'm going to compare what we do on the user account side and what similar controls you could do on the workload identity side. So first of all, for strong credentials. So we know for our users, we want to be using modern password guidance. We want to make sure that those passwords aren't easy to guess. We want to discourage password reuse and arbitrary rules that start patterns like spring 2022, at the end of every password that you reset once a quarter, or also even better, leveraging those FIDO2 keys. Now, on the workload identity side, it's very similar. So you're going to want to be using X509 certs or managed identities instead of client secrets. So just something that is a more strong credential. Also, be sure to monitor applications to ensure that they don't have very long credential expiration times. So I've worked with some customers where their apps are set to expire. I've seen as high as 99 years from now, which for reference, the NIST standard is just 1 year. So if you have an app that's set to expire by the time all of us are, I'd imagine, no longer on this earth, that's probably not a great way of, managing your application. So be sure to replace those with a shorter lifespan and ideally apply to those standards that are in place. And we mentioned this earlier, but ensure that credentials don't get committed to code repositories, and be sure to educate your developers on proper ways of doing this. Now, when we talk about least privilege, again, something that y'all are probably familiar with on the user side, only assigning those admin roles when necessary. Not everybody needs global admin, and ensuring that you could use just in time or just enough elevation whenever possible. For workload identities, it's similar. So think of those application permissions like your admin roles and permissions, and ensure that they're only used when they're needed. And I think that this is something that goes back to speaking with your developers. We've all been there where we're just trying to get our code to work and trying to get it to run. And we'll use those .star permissions or those higher permissions just to get something to work. Or you think that, maybe I need to be able to write to this user instead of just read it. So be sure to educate your developers on using limited permissions, and also identify existing applications that have high privilege permissions that they might very well need, and just be ensured that monitoring them is on your radar, because if that app does get compromised, it's analogous to a bad actor being able to get an admin account with similar admin permissions. I want you to view those two similarly. Something else is to consider limiting end user consent. In Azure AD, there's 3 ways to do this, and I'm sure with your IDP of choice, it might have a similar process to it, but the way I'm familiar with is that you can either block all end user consent, which if you're in a highly regulated organization, it may make sense for you where you just don't want any users to be consenting to any applications ever. It might make sense for you. There's a Goldilocks option in between that is to allow end users to consent to apps from verified publishers with lower risk permissions, or lower impact permissions rather, that you can preset as an admin. So that's something that is a little bit of a balance that you're able to control, balances the business uses that those users need with also the security needs that you have. And then you can also just allow end users to consent to absolutely anything, like the wild, wild west. I wouldn't encourage you to use that option, but I think that, if you can consider limiting end user consent for what makes sense for your business, definitely do so. And if that end user consent is blocked for whatever reason, then be sure to investigate that and analyze why that might be blocked, because it could be indicative of something larger that you might not be seeing yet. On the lifecycle management side, we know to not leave stale accounts lying around for a potential bad actor to leverage. We also know to recertify access for those accounts. On the workload identity side, it is similar as well. Clean up stale apps and credentials, recertify access for those apps if they need it, monitor those apps with the high permissions, and then again, as I mentioned earlier, lower those application permissions whenever necessary. If you can, even if there's an app that is developed in-house, potentially check in every once in a while to see if they still need certain permissions that are there, especially if they're not using them today. So that way you can trim them down a little bit. Now on the monitoring anomalies, so earlier we talked about setting a baseline, because if you don't have a baseline, there's no way for you to monitor if something is irregular or abnormal, because you have nothing really to compare it to. So be sure that you have a baseline in place first. But on the user side, we're familiar with, if I am logging in from unfamiliar locations, like if I log in from London tomorrow, that's not very typical for me logging in from Seattle, Washington every day of the week. And, from the same device I always am, at the same time I always am. That's something that's very typical for me as a user. And similarly, on the workload identity front, you want to monitor for those changes that seem a little weird. So if there's any sort of change to the URI of an app, you want to make sure that an end user potentially isn't getting phished, and that the app isn't being redirected to something potentially malicious. If there's changes to application owners that's, perhaps done outside of normal processes, something you're not aware of, that could also be indicative of something, that you would need to go look into. If those logout URLs are modified, and then also, of course, if there are unauthorized changes to those credentials, similarly as you would monitor for an end user. Now we do have some pre-built monitoring and alerts, and I'll be sure to pop these in the chats once I hand it off. But these are just things that if you do leverage certain, Azure AD or Microsoft products, it'll make your life a little bit easier. But again, all these docs can be readily applied to your IDP or your, product of choice, because it's the same concepts, just with a different product.
Cool, thanks, Bailey. I think it would be good to show you all a little bit of a demo of what we're doing in Azure AD today, just for illustration purposes, and get a sense of we shared a lot of things that you can do manually today, but some of the things have been automated for you. Some of the tooling here, we're doing some of the work for you. So by all means, take a look at this. If you're not using Azure AD, it's fine. Just take this with a grain of salt. So the first thing I want to show you is how to use conditional access to lock down actual sign-ins by a workload identity. And the way, for those who aren't familiar with Azure AD conditional access, it's a policy engine for access control. So it's basically a series of if-then statements. If these conditions are satisfied, then do this thing. For the purposes of workload identities today, all of the then statements is going to be blocked. Like with users today, you can do if there's a risky sign-in, then challenge with MFA. But today, workload identity, the only control we have is block. It's a relatively new capability. That's what we're doing right now. So, but we're going to look at a few of the conditions. We're going to look at location-based conditions. So I'm going to restrict access based on where the workload identity is calling in from. And we're going to also restrict based on risk, which has Azure AD Identity Protection found some risk that justifies blocking this. Okay, so let me walk you through these. So here, what I'm showing on the screen is the process to create a new conditional access policy. And I go to the policy blade and I select workload identities from the dropdown. And in this particular case, I'm going to select specific service principals. So by the way, service principal is the specific name for a security principle in Azure AD that's for an application. So that's kind of a unique term of art, but that's what service principal means. So I'm going to select a specific service principal in this one, just for the purposes of the example. And I'm going to have it apply to all cloud apps, which means no matter what the service principal is trying to access, whether it's trying to access mail or some financial app, whatever, it's going to apply to all the apps, all the resources, okay? And then I'm going to set my conditions. So here I'm going to set a location condition. And the way this is going to work is I'm going to, sorry, I'm just trying to advance my slide here. No. Sorry, some latency. I'm going to apply this to include any location. So what I'm going to be saying is I want to block any location that this is calling in from, but I'm going to exclude trusted locations. So separately, I have configured some trusted locations like my data center or my partner's data center in some way to say, all right, we're going to allow sign-ins to come in from these locations, from these IP ranges, essentially. You could do this by country. That's not very specific, but you get the idea. So basically what's going to happen with this policy is it's going to block all token issuance for the service principal, except for those that are within a trusted location. The other condition I can use is I can use risk. Risk is where our system is, again, detecting risk. And I'm going to show you what that looks like in a minute. so that you can actually say, if risk is detected, then I want to block access on either high risk or medium risk or low risk or some combination thereof. So once I have it set up, you can see I've got it selected to block access. I enable the policy. So if it's on, it means it's going to run right away and enforce right away. I can also put it into something called report only mode down here in the corner, which is basically putting it into like an audit mode, which means that the policy will run in the background. It won't actually do any blocking, but it will log what would have happened. And this allows you to like slight the policy before you actually enforce it. If I go to the workbooks blade in Azure AD, I can see some access to the insights and reporting for this particular area. And it'll actually give me a report of which service principals would have been successful sign-ins, which ones would have failed because of the policy, and which ones were simply not in scope of the policy, maybe because they were some other app, or they didn't fit the criteria. So let's go over to the identity protection blade. So again, identity protection is a risk-based detection engine within Azure AD. It's been around for several years for users, and there are all sorts of detections that we have there around detecting password spray, detecting token theft. I mean, you name it. I'll post to the documentation, but it's a fairly mature product. In February of this last year, we launched workload identity, risky workload identities. And so what that allows you to do is to start to monitor for threats against applications within your own environment. So in this particular example I'm showing, there is a list of applications that have been flagged for risk. And all of these applications, there could be a different reason why. Like, we're going to go into the detections, but this is the account level risk, right? So every single application has its own identity, i.e. its own account, but the risk level is actually fed by something called detections. I'll get into that in a second. So here you have the basic information about, what is the status of it? Is the application enabled or disabled? There's also certain controls we have here. You can confirm that it's compromised. You can dismiss the risk and just get rid of the risk. You can enable or disable it here. You can also look into the sign-in logs and audit logs. Remember, we talked about that earlier. So we've given you links into doing your investigation here. And if you go into the detections blade, which is a separate blade in the same area, you can see a specific list of the detections. And there's several different kinds here. We talked about lead credentials. That's one that's super impactful for us and our customers, where we are detecting plain text credentials in public GitHub repositories. That'll expand over time to other types of repositories, but for now, that's what we're covering. And when we do that, we actually point straight to the repo. I'll show you an example in a minute. Another really key thing that we have done is we've actually integrated with another product called Microsoft Defender for Cloud Apps, formerly known as MCAS. And this detects the unusual addition of credentials to an OAuth app. So you remember when I showed you the attack graph, we showed how one of the ways that attackers obfuscate their activity is by adding a new credential to the application. So we've seen that as a threat. We're notifying you about it here. And that's why you see the event there. If I take you to what it looks like, if you were to click on the hyperlink at the bottom of the lead credentials, where it's set in the lower right, which is click here for more details, it would take you actually to the specific repository for a given GitHub a GitHub page artifact, and it'll actually show the secret. It'll show all the details, which is like why this was discovered, and yet there you'd be able to say, okay, well, who committed this to the code, and then you'll be able to go remediate. And we give you the specific guidance. If you look at the IR playbooks, we give you the specific guidance on what to do in this case. So I hope this gives you a sense of like, what are we kind of doing? How are we trying to automate and make this a little bit easier for you to find this? Let me turn it back over to Bailey to close us out with some go-dos.
Awesome. And so thank you so much for letting us be here today. We do have just a couple go-dos for y'all. So if you take nothing else away from the conversation today, please just take these. So first of all, we demoed a little bit about what this looks like in Azure AD. Same principles apply to whatever you use, but try these features out and be sure to test out, what it looks like for, an overprivileged or a malicious or compromised app in your environment and what you can do about it. based off of what we've shown you today. Also, I have 2 links here for you. So there's aka.ms/Azure AD SecOps, and then also our IR playbooks. And both of those are just some great guides for you to get started. On the SecOps guide, we also have several other different sections that cover different, security and operations areas within Azure AD. But again, those principles apply for whatever you use. And we were heavy contributors to the application section, so it'll have a bit of info for you there as well. And identify your app owners. So a lot of organizations, they have so many different apps and they don't know who owns it. So if there's something that you could do this week, next week as like a little homework assignment, is to go and identify those app owners and make sure you know who they are before something potentially were to happen. And with that, I have a couple of links also to close us out that I'll be sure to put in the Slack. I know there's a lot of questions there too. So if there is time, happy to answer them on here, but also we can go through and answer them on Slack after the fact. We're both very active on Twitter. And so I'll be sure to also put our Twitter handles in the Slack as well. With that, we're really grateful for y'all having us here.